Hey everyone, welcome back to Case 23, where we decode forensic science in fun and simple way. Today's video is going to be a blast, quite literally. We are diving into the world of explosives and how forensic science plays a crucial role in investigating bomb-related crime scenes. I'm sure many of you have heard about the infamous Taj Hotel attack in Mumbai or the Hyderabad twin blast, both terrifying incidents where explosives were used. Here are just a few examples where forensic experts stepped in to collect clues, examine the blast scene, and even help identify the people behind the crime. So if you are curious to know how investigators handle such explosive cases, or what kind of evidence they look for, and even how they pieced everything together, you are in the right place. So let's get into it. Alright, so here's what we have got lined up for this video. First, we will kick things off with a quick introduction to explosives, what they are, how they work, and where they are commonly used. Then, we will look into their classifications because not all explosives are the same. And after that, we will explore the different types of evidence found at a blast scene and how forensic experts collect them. We will also go over the detection tools, yes, including bomb sniffing dogs and as well as high-tech machines. Then comes the heart of it, the techniques used in forensic analysis, and how the labs find out what kind of explosives was used, and even who might have handled them. Finally, we will end this video with real-world challenges that forensic experts face during such investigations. So yeah, it's going to be packed with action and science. Let's jump in. Alright, then first let's start with introduction. But before that, let's begin by understanding what explosives actually are. So an explosive is a chemical substance or a mixture of that. When it gets the right trigger, usually a spark, impact or heat, reacts extremely fast, releasing a huge amount of energy. And this energy comes out as heat, light, pressure and shock waves, which is why explosives cause such intense damage. And now explosives can be of different types. They might be an element like uranium, a compound like TNT or RDX, or even a mixture like black powder or chlorate nitrate combinations, often found in improvised explosive devices, also known as IED. And here's something important to note. In most criminal investigations, the explosives found are chemical compounds or mixtures, not pure elements. That's what forensic experts focus on while analyzing blast sites. So having a solid understanding of what explosives are and how they are classified is the first step in investigating any explosion scene. Next, let's talk about why explosives are widely abused in criminal activities. First up, availability. The materials used to make explosives or even pre-made products are often easy to get. Many of them are sold legally for industrial or agricultural use. Then there's improvisation. IEDs or improvised explosive devices can be made using everyday items, and honestly, it doesn't take a genius to put on together a little know-how and you have got a deadly device. Concealment is another reason. Explosives can be hidden in the most ordinary objects like bags, lunch boxes, vehicles. That's why making them hard to detect until it's too late. Then it is affordability, which is also a factor. Ingredients like ammonium nitrate are cheap and easily available, which make it budget-friendly for criminals. Next is the fear impact. One explosion can cause mass panic, public insecurity, and psychological trauma, making it a terrifying weapon of choice. And finally, low evidence. Most explosions leave behind very few and even contaminated traces, which make it more harder for investigators to track down the culprit. These are the reasons why explosives continue to be one of the most misused and dangerous tools in the world of crime. Now let's talk about the classification, because all the explosives are classified into different types. So to begin with the classes of explosives, they are categorized based on two main factors, speed and sensitivity. Let's start with speed, or more technically the velocity of the reaction. First we have low explosives. These have a burning speed ranging from 200 to 900 meters per second. In some cases, it can go up to 2000 meters per second. But remember, they burn, they don't detonate. A good example, black powder or gunpowder. They are mainly used as propellants like in bullets or fireworks. Then we have high explosives. Now these are the serious ones. They detonate with speed ranging from 2000 to 9000 meters per second. That's like a shock wave tearing through everything in its path. Examples include TNT, RDX and PETN. Now switching over to the other side, we talk about sensitivity. And for sensitivity, we first have primary explosives. These are very sensitive to heat, friction or shock. They are the ones used to initiate the explosions. Think of them like the matchstick that lights the fire. And then come the secondary explosives. They are less sensitive but way more powerful. They need a detonator or a blast from a primary explosive to set them off. TNT and RDX fall in this category too. So now let's dive deep into these explosives. First, let us start with low explosives. They are also known as deflagrating explosives, and instead of detonating with a sudden bang, they burn very quickly. Their burning speed usually ranges between 200 to 900 meters per second, and in some cases it can go up to 2000 meters per second. Now what happens when they burn? They produce a lot of gas which create pressure in closed spaces. If that pressure builds up, it can cause damage. But usually they don't rupture containers unless they are tightly sealed or misused. A few common examples are gunpowder, nitrocellulose and firecracker powders. You'll mostly see these in fireworks or used as propellants in small firearms. But keep in mind, in confined conditions like inside a sealed container, even gunpowder can behave like a high explosive and cause a serious blast. Now let's talk about high explosives. These explode very rapidly through a reaction called detonation, with speeds ranging from 2000 to 9000 meters per second. So when they detonate, they release a powerful shock wave that can break containers and cause massive damage in the surrounding area. What's interesting is that the blast usually moves in the direction of least resistance, like in open spaces. And unlike low explosives, they don't need to be in a closed space to explode. It is what makes them so versatile and destructive. Now, because of the intense power, high explosives are commonly used in the military, demolition of buildings, and blasting operations. And just to give you a better idea, here is a table showing some of the most commonly used high explosives along with their detonation speeds. Next, we have primary explosives, which are classified based on their sensitivity. These explosives are extremely sensitive to heat, impact, friction, or even a tiny electric spark. Because of this, they can explode very easily, even with a small force. They don't just burn, they detonate, and that's why they are usually used in small amounts to start explosions. You will mostly find them in blasting caps, detonators, and gun primers, where their job is to trigger secondary explosives which do the main blasting work. Since they are so sensitive, they can be very dangerous to handle in large quantities. Common examples include mercury fulminate, lead or silver azide, lead stiffenate, tetrazine, and dianol, all widely used for initiating blasts. Moving on to the secondary explosives, they are less sensitive than primary ones, which means they are safer to manufacture, handle, and transport. But since they don't explode as easily, they usually require a small amount of primary explosive like a detonator to kick things off. You will find secondary explosives being used as the main charge in bombs, military-grade explosives, and in demolition operations. Some of the most common ones include TNT, RDX, HMX, and PETN. And just a quick note, RDX, ammonium nitrate, and gelatin sticks are often used in blasts reported in India, especially in cases related to terrorism, mining, and criminal acts. There's also a third type known as tertiary explosive. These are very insensitive to shock, which means they can't be detonated by primary explosives alone. Instead, they need a booster of secondary explosives to go off. We'll commonly find tertiary explosives used in mining and construction, mainly because they are cost-effective and safe to handle in large quantities. They are typically a mix of a fuel and an oxidizer. One well-known example is ANFO, which stands for ammonium nitrate fuel oil. It is especially useful when the reaction rate needs to be slow, like in controlled demolitions or large-scale excavation work. Next up, let's explore the various detection tools used for identifying and analyzing explosives. So first, let's talk about one of the most loyal and effective tools in explosive detection, that is detective dogs, also known as sniffer dogs. Now, these dogs are widely used in the field due to their highly sensitive sense of smell, sharp hearing, and strong memory. Their natural abilities make them perfect for detecting even trace amounts of explosives. But to perform at their best, these dogs must be in good health, receive proper training, and most importantly, they must always work with the same trained handler. This consistent partnership is key for effective communication and trust. The handler plays a major role too. They need to be intelligent, experienced, and above all, a genuine dog lover, because building mutual trust enhances teamwork. Among the various breeds, German Shepherds are one of the most preferred choices for explosive detection, thanks to their intelligence, obedience, and strong work ethics. Then let's talk about something you have definitely seen in airports, the X-ray machine. Now, this machine plays a huge role in keeping passengers safe. They are commonly used in airport security checkpoints to detect firearms and any other potential bombs that could be hidden in luggages. So how do they work? Well, it's pretty clever. X-ray machines pass X-rays through the bags, and these rays create detailed images that the operator can examine right there on the screen. This helps them to spot anything suspicious. And there's something more. They are really useful in identifying improvised explosive devices or IEDs. Things like clocks or metal parts inside these devices can often be picked up clearly on the X-ray images. Modern X-ray machines have seriously leveled up. They now use both hard and soft X-rays combined with advanced computer processing. This powerful combo allows the system to automatically alert security officers if it suspects that there might be explosive inside the bag. Let's move on to another fascinating technique used in explosive detection, ion mobility spectroscopy or IMS. This method is seriously impressive. IMS is a fast and super effective gas phase technique that is widely used for detecting trace amounts of explosive, especially in airports where quick detections are critical. Here's how it works. The system operates under what's called negative ion conditions. This setup makes it perfect for identifying not only the explosive residues, but even dangerous chemical warfare agents. So it's not just about the bombs. It can catch a whole range of hazardous substances. What makes IMS even more powerful is its sensitivity. The detector actually analyzes the air samples taken right above the explosives. That is known as the headspace. Now doing this, it can spot volatile compounds that are released even from plastic explosives, which are usually very hard to detect. And now let's talk about something really crucial in the fight against explosives, the role of forensic science. Before continuing, let's first go through the topic importance of forensic analysis. As you can see here, forensic analysis plays a crucial role in multiple areas, starting with national security. Explosive analysis is essential for detecting and preventing terrorist attacks, safeguarding national assets, and maintaining international security across India. Moving on to conflict zones, it helps trace the origins and methods of explosives in sensitive regions like Jammu and Kashmir, Northeast India, and areas affected by Naxalite activities. Next, we have public safety. Forensic analysis supports investigations of blasts in crowded areas, ensuring a quick response and helping to prevent future incidents. And then there's legal evidence. Forensic findings are admissible in court, helping to link suspects to the explosive and strengthening cases for successful convictions. And finally, illicit activities. Forensic science aids in tracking smuggling and illegal manufacturing of explosives, assisting intelligence agencies in preventing unauthorized use and tracing the sources effectively. Now let's talk about the role of forensic scientists in explosive crime scenes. This is all about getting hands dirty at the blast site, collecting residues, fragments, and any physical evidence left behind. Think of it like putting together the first piece of a complex puzzle. Next, we dive into the explosive identification. Back in the lab, experts run detailed tests to figure out exactly what type of explosive was used. And if we are lucky, we might even trace it back to its source. Then comes device reconstruction. Here, the forensic teams actually rebuild the IED to understand how it was designed and how it worked. It's a bit like reverse engineering the criminal's thought process. And finally, linking to suspects. This is where all the hard work pays off, matching the materials or methods known to suspects or previous incidents. It is that moment where the investigation starts pointing towards the culprit. Then let's talk about the types of evidence collected. This is where the investigation really takes shape. First, we have explosive residues. After an explosion, tiny chemical traces are left behind, and trust me, these little clues are gold. They help experts figure out exactly what type of explosive was used. Then comes shrapnel, wires, and electronic parts. These recovered components are like pieces of a mechanical puzzle. By studying them, forensic teams can rebuild the device and understand how it worked. Next, clothing, containers, and soil samples. These might seem ordinary, but they often carry residues or trace evidences that can link suspects or even specific locations to the blast. And of course, we can't forget trace evidence. Fingerprints and DNA. This is the most direct link to the individuals involved. A single fingerprint or strand of DNA can place someone at the crime scene or in contact with the device. Next, let's dive into the techniques of evidence analysis. Now, this is where science steps in to turn those tiny clues into powerful revelations. First up, we have microscopic examination. This technique zooms right into the tiniest particles, fragments, or residues left behind. It helps us uncover the physical structure, surface details, and even the subtle manufacturing marks that can tell a deeper story. Next up is the thin layer chromatography, or TLC for short. Now, it is a fast and cost-effective technique that helps us separate the different components within an explosive mixture. Think of it as a quick sorting process, perfect for preliminary identification of organic explosives. Before we move on to more advanced analysis, TLC gives us an early idea of what we're dealing with, helping narrow down possibilities efficiently. And then the next techniques is the heavy hitters, gas chromatography and mass spectrometry, or GCMS. This powerful technique combines two things, separation and precise identification. It can detect even the tiniest trace amounts of explosive materials with incredible accuracy and reliability. Basically, if there's even a hint of explosive residues, GCMS will find it. It is one of the go-to methods in forensic labs for its ability to deliver clear, trustworthy results. Moving on, we have Fourier transform infrared spectroscopy, or FTIR. This technique is all about understanding how different chemical compounds absorb infrared. Every substance has its own unique absorption fingerprint, and FTIR reads that signature to help us identify what's present. It is especially useful when we are analyzing organic explosives and binders, whether they are in solid or liquid form. With FTIR, even complex mixtures start to make sense. And then next we have ion chromatography. This technique is specially designed to detect inorganic ions like nitrates, chlorates, and perchlorates. These compounds are commonly found in both commercial and homemade explosives. Ion chromatography helps forensic experts pinpoint these substances with precision, giving crucial insights into the composition of the explosive and sometimes even clues about its origin. Finally, we have scanning electron microscopy with energy dispersion X-ray, or SEM-EDX. Quite a mouthful, but incredibly powerful. This technique gives us super high resolution images of even the tiniest residue particles. But that's not all. It also tells us exactly what elements those particles are made of. SEM-EDX is essential for confirming the presence of explosive residues, and even better, it helps us link the residues back to the source materials. It is like having a forensic magnifying glass and a chemical detective all in one. And finally, let's talk about the challenges forensic experts face in explosive related cases. Now, it is not as simple as finding debris. First, they need to confirm whether the material is actually explosive and whether the device used was a homemade ID or a military grade bomb. By carefully studying how the device was made and how it was triggered, they start to piece together the attacker's method and level of expertise. Components like wires, switches, or batteries can reveal crucial details about how the bomb was set off, and sometimes even where the materials were sourced from. Experts also compare the design of the device to those from previous cases. So here, if they spot similarities, it could point directly to known suspects or patterns. And let's not forget the tiniest pieces of evidence. Traces of explosives on someone's clothes or hand can become powerful proof in court. Finally, the forensic experts work to answer one of the biggest questions. Was the explosion an accident or a deliberate attack? Clues from the scene, no matter how small, help them uncover the truth. And that brings us to the end of this video. Thank you for watching. If you have found this video interesting, don't forget to like, share, and subscribe for more deep dives in the world of forensics. See you in the next one. Till then, bye bye.